Good afternoon, morning, evening, depending on where you're listening to from today, and welcome to the Senturus webinar series. Today's soup du jour is good data models lead to great BI. Today's agenda, we'll start off with some introductions. We'll talk about, is data modeling still relevant? Why is data modeling important? What is a data model? We'll do some live demos. We'll do a quick overview of Senturus and some additional resources that we have, and then we'll end up with a Q&A of some of your questions and hopefully get answers to you. Joining us today is Andy Kinnear. Andy is a certified Microsoft Business Intelligence architect and a developer with over 20 years of experience in software development. Andy has made regular appearances at the Power Platform World Tour event over the years. He also serves as the assistant organizer of the New Jersey, New York branch of the Power BI user groups. My name is Todd Schumann, and I'll be the host today. I run the installations, upgrades, and optimization practice at Senturus. You may recognize me from other amazing webinars, such as Cognos Analytics performance tuning tips and tips for installing Cognos 11. With that said, I'd like to turn it over to Andy, who will take you through today's presentation.
Thanks, Todd. Appreciate it. Hello, everyone. What we'll talk about today is whether or not data modeling is still relevant. And let's dive right in. So new tech replaced modeling, right? And this is kind of the big question out there, big data technologies and taking your stuff and throwing it into a data lake. And a lot of people are out there saying, all you need to do is throw your data in a data lake and apply it to this third-party tool and then do analytics right away and get the answers you need. And that's is a lot to be said for that with big data technologies. And one of the reasons that it came about was that it was too hard to say load into a data warehouse. And a data warehouse, we're going to talk a little bit more about that, but it is essentially taking a dimensional model and then loading that dimensional model as a data warehousing process. So in the compare contrast of what we're going to talk about a little today is whether or not big data technologies have discarded the use for a good dimensional model. And there are claims that that's the case. But very recently, we've had a chance in the big data world where they've actually created some technologies where you can do some of the things, like for instance, inserts, updates, and deletes on files that are in a data warehouse, in a data lake, and then have the same type of analytics off of that dimensional model. So it's interesting that for a while when people are saying that the dimensional model is no longer needed, you don't have to spend your time doing that. But now, since the technology is there to do it, they've come up with what they call a data lake house, which is one way of achieving both big data technologies and a dimensional model in a data lake environment. So it's an interesting topic at this point. With the lake house, the data lake house, what it attempts to do, there's a data warehouse here that does this, there's a data lake that does this, and this data lake house kind of combines. And then back once again is our data model, our dimensional model that we do. And it's both in a data lake house or in a data warehouse piece. And these are big data technologies. These are high-minded concepts from an architectural perspective in an organization. How do we go about getting the data out to our people so that they can make good business decisions? And whether or not the data model process is the right way to go, or is it still even useful in today's world? The old and new are conversion, and that's what the prior slide had just shown. The big data processing is now heading towards dimensional modeling, the data lakehouse concept. Data warehousing has had big data processing for a while. They noticed that with very large companies, very large amount of data coming in. So how do we load a data warehouse overnight? It takes 30 hours for me to load my data warehouse. We have so much data. So you couldn't do that. Amazon couldn't do that. Facebook couldn't do that. All these companies had tremendous amounts of data coming in. So the data warehousing concept had to be put on the side, and big data concepts came into play. So they came up with techniques to the map reduce technique, which evolved into a number of tools taking something similar to that so that you can scale out processing power and memory and then do analytics on very large amounts of data. And with the data warehousing tools that were out there, they had, if you do have the ability to load a data warehouse overnight or in a certain sequence of time, say every hour or so, then we still have very large amounts of data, and we need to be able to scale that out in this technology of massively parallel processing, or MPP, appliances that were created some 15 to 20 years ago in the data warehousing world, and now are part of the cloud platforms out there. So data warehousing has evolved into big data in terms of scaling out to multiple processes and memory. So why is data modeling important? What does it do? What does it serve us? And this is just a great question from a business standpoint. And I've had many conversations with people, especially on the big data side, good big data architects who are very good at the process that handle it. And they normally there's I should say, I've had many times where they just don't understand the idea of why we'd want a data model or put the effort into building it. And there is effort, so there is upfront effort that's important. But it's always important to show the end result of it. And that's one of the things we'll do in this webinar, is we're going to show some demos at the end as to why a data model is still important and relevant, as we said before. From a bullet points perspective, ease of use. It's easy to understand. So we are used to seeing dimensions and fact tables that represent either the nouns in our organization, and for nouns you would say as a dimension is product, company, date. You know, these are things that we understand from a company perspective. If we're reporting on it, I want information about a customer. It makes sense to have a dimension called dim customer or dim product. And then fact tables that go with it. So a fact table is an event in an organization. I made a sale. A sale gets recorded as a transaction in a database. And we put them into fact tables in a dimensional model. And from that perspective, we know that a fact table has an event that's associated with it. So if I'm looking at fact sales orders, I know what that is. It's an order that came in, and I have a certain date that's applied to that. And if I want to see my customers breaking down into their orders, then I have a relationship between fact and dimension, and it's easy enough to drag and drop in a tool, a third-party tool that's made for it. It is very performant. So there is this process, won't go too much into at this point, but denormalization, where we take something and we make it into a customer table, be a very wide table with many columns. It's not going to be a table that relates to another table, say an address table, which relates then to a state table, and then relates to, let's say, a country table. So in this case, we have one customer table. We move all those fields into that customer table, and we just have one relationship back to the fact table. And that makes this highly performant, especially since in the last 10 years or so, column store indexing that's come out. It's made for that sort of process to be very fast. Tracking history, that's a technique that we'll show later on, where we can track history within a dimension and tie that history into a fact table so that you don't have to know about behind the scenes what's taking place. These models are ready for ad hoc analysis. A lot of the tools are used to the dimensional fact table approach, and they bring the model in, and then you just do a lot of drag and drop. And that's using third-party tools such as Power BI, Cognos, Click, Tableau, amongst others. The first reason for having a model, and this goes back to the 90s when they said, you know, when I wanted to make a report on something, I wanted well, let's just say an application like Amazon first came out. It's got a transaction database behind the scenes. When I go to place an order, it had a very efficient database that took into account my order from the list of products, from my information, and created an order in their system. And that's called transactional processing in the database world. And it's great for feeding an application. So if I call up and I'm saying, where's my order? It's not received yet. Then someone looks on the screen, pulls up a form, says, I want to see this order number from Mr. Kinnear, and then there it is. And those databases were built to make that process very efficient. Now, the problem came about was when some analysts said, well, I want to see what this product has done over the last 6 months. And then I want to compare it to the same 6-month period from the prior year. And so someone would write a very complicated piece of code, and then they would run it on the system. And with very large systems, then you'd have, it may take a half hour to run. And during that half hour, when people are trying to place orders or customer service is trying to service requests, the system is now bogged down by that reporting requirement and that query that's running in the background. And so the first dimensional model was to move of the application side, and so that it doesn't interfere with people basically giving you money, right? Which is the idea behind the transactional database. You want to send money in your application. And then cost is an interesting part of this. So cost has always been what a lot of people think is a downside to the data warehousing dimensional modeling process. And there is upfront cost, yes, there is. But time, the reusability and the scalability of the environment reduce the amount of time it spends on query report development. So it's an important part. I don't know, had a situation where as an analyst at a company, you spend a lot of time pulling data into Excel and then mashing it up with VLOOKUPs and putting in calculations. And every week I have to do this. Now I have to pull this new data in. It takes me a little time to do that. I've got to parcel it out to different people in the company so that they get to see theirs. All it takes a amount of time from people that should be spending their time on business decisions. And that's the purpose of analytics, is that to be given the data and I look at the data and I see the data and I something say, we need to create a campaign now to handle one product line. And now I'm going over and I'll make a presentation to the marketing department. And that's what analytics should do for a company. It should make the company better in some fashion or another. And we want analysts to be spending their time thinking about that to make those decisions rather than working in terms of bringing all this data together and then mashing it up, which a lot of analysts do spend a lot of time on. So the model does handle that. And even though there is upfront cost, in the end, you should be a much more efficient company because of the process. And you should be a much more profitable company because of that. We're making better, more timely business decisions. That ends up in more profit. So what is the cost of a dimensional modeling? And then how does that all work together? So without a dimensional model, you wouldn't be able to do some of the historical changes. And we use these terms SCD1, SCD2. It stands for slowly changing dimension, which tracks some of the historical changes, and there's different types of that. By formatting dimensions and facts, the user doesn't need to know about the programming. Just once it's done, it gets handled overnight, and it's done, and it's all set. So the fact tables and dimensions are tied together. So the user just has to drag and drop and get that. Now, if you are doing that off of a file or a number of files from a data lake or just cobbling data together, then typically you don't have the ability to do that. This is one of the big advantages of having the dimensional model, is that ability to track historical changes over time. Shared dimensions, another big part of the process is with having different dimensions that hook into, or having one dimension that hooks into many different business processes. The fact tables are typically business processes, a sales order, a purchase, inventory. These are all business processes that hook into a single product dimension and a single date dimension. And because of that, we can report on those things over time and in the same report. And it's all there for you. So again, the whole idea of providing this to an analyst so that it becomes drag and drop, filter and slice type of functionality. And then the date dimension, and this is something that a lot of the third-party tools now have down pretty solid. They have a way of, you can right-click a date, I believe in Tableau, where you just say, let me see the last 6 months. So everything's relative to whatever you're trying to do with a single date. And the date dimension in the model is something that gives you a lot of flexibility. So I have a date on my fact table, one date, and I have it connected to this date dimension. And so if I want to see analytics over the last 4 years, then I can choose calendar year and have that, take a look at it. And then if I want to see it by month, I just take the year out and I grab a month field and I pull that in, and off it goes. So it's very flexible, and with date dimension, you can have many, many columns. That's the other part of it, is it's connected with one key. You can have many fields that are that are normally not available unless your business has a particular reason for it. Fiscal calendars are a good example. What is a data model? So what are we talking about? And I've thrown some terms around here. I hope everyone can understand, but let me take a moment to work with some of that. The data model versus what a data warehouse is. So a data model could be anything from the sense of what I mentioned before with Excel. If you pull in different sources into Excel and mash it up and create some calculations, that is a data model. It is a simplistic one. It's done ad hoc, but it's still considered a data model. Dimensional model takes it a step further. It's a very specific construct, dimensions and facts, and there are different types of dimensional modeling, but standard way, and the one we'll demo today, is a Kimball method data model, which is comprised of dimensions and facts. A data warehouse is a place where we store those dimensions and facts in the forms of tables in the database. And when the data gets loaded in, it goes through many processes. The data warehouse, many processes, an ETL or ELT, which stands for either extract, transform, and load, or as the other model is extract, load, and transform. In the end, you end up with tables and that are either dimensions or facts in the dimensional model. And they are database tables, or in the new data lakehouse experience, it could be files in a data lake. All right, but they are essentially, when I say tables or files, we're looking at columns and rows, and then all interrelated. What a data warehouse is not. So this is interesting. We now have this system of data warehousing. I'm sure many of you have been in a company where it says, oh yeah, we have data in a data warehouse. We have a data warehouse for everything. Oh, good. And you go and take a look and you say, well, it's not really a data warehouse. It's something we would call an operational data store, which is to say you can have a replicated version of the application database and have it off into its own own server, so that doesn't interfere with the application side. And we addressed that earlier. With the application side, you don't want to run reports on the application database. And so the first thing people thought, well, let's get that over to a different server. There are replication technologies and databases so that if an order gets placed in the one system, it just does a second insert into the other system. And it's a very efficient way of handling, keep the systems in sync, and then the reporting people would just report against the operational data store and not interfere with the application database. And that's very efficient for removing the load off the application side. But a transactional database is not set up in the right way to handle analytics. And I guess that example that I mentioned before, if we had I wanted to see what this product did in the last 6 months and compare it to the 6 months of the same period last year, that's not an easy thing. And it's something that you have to do some complicated SQL to write it. You have to do a lot of different things in order to do it, and then it could take some time as well. With the dimensional model, we take that transactional data, we move it into tables, dimensions, and facts, so that particular process, which I just mentioned, 6 months over 6 months, is much more easier to do. A place to store tables built to service one report. So this is, again, what a data warehouse is not. People that have had what they call data warehouses, and basically, let's take that example of the last 6 months over the prior 6 months, and you say, all right, well, it's complicated SQL, takes about a half hour to run. I'm going to now run that overnight and then store the results in the database. And that table will then service the report. So when someone gets on a report the next day, it's a quick and easy report reading directly off the table. It doesn't have to involve a complicated SQL. So that's also a good step in the right direction from an operational data store perspective. But what quickly happens is everyone tries to service all of these requirements, and so you get many and many tables, a lot of it with duplicated data all over the place, and it kind of grows into a maintainable mess, an unmaintainable mess, I should say. So again, it's not a place where you're just storing constantly temporary tables so that it can service one report. And it's not a data lake. Data lake has a very specific use case, and it is a great thing for us in the data world that this has come about, that we have a place we can store any kind of data, whether it's structured data or unstructured data. It could be videos or images or documents, things that don't have a tabular structure, and we throw it into the data lake. And then there are techniques that are made around that so that you can do analytics off of those type of data types. So it is not, the data lake has a wonderful use, but it is not, a data warehouse is not a data lake. I'm going to go through this kind of quickly. Inman versus Kimball in the data warehouse methodology. So these two, the first to come up with data warehousing in the mid-90s, and Kimball has pretty much emerged as the one that's used most often, and we're going to follow that today in our presentation. I'm suggesting everyone, if you want to get a little better understanding, just Google Inman versus Kimball, and you'll see plenty of good articles out there that would stress the differences between the two. Data Vault is also, it's not quite data warehousing, but it is a construct that has been made for larger organizations to kind of make scalability easier. If you want to look into the Data Vault technologies as well, please do. For this, we're going to look at the Kimball method star schema approach, and that's the idea of having a fact table with one relation to each of the dimensions, right? So that, again, reduces the relationships and the query. I lost a word here. So just how complicated a query can be. It's now much less complicated and simplified when you only have the one relationship in here to worry about. And with fact tables, you can have many fact tables, even though a star schema is shown here. You have one point in the middle that kind of reaches out and star, gives it a nice star schema. But for the most part with data warehousing, you have many fact tables that can connect to the same dimensions. And that gives you a good way to combine the different business processes and report upon them across shared dimensions. Okay, so Kimball methodology. Dimensions are the nouns of the organization. You have customer, product, employee. These are all nouns. And then within the nouns are these attributes. Now, a dimension is nothing more than a table in a database. Right? We're using it as terminology. We're calling them dimensions because it's a certain constructed table. And an attribute is nothing more than a field within that table. But the idea is that an attribute describes the dimension. So if you can see here, first name is an attribute of the employee dimension, describes the employee. Color is an attribute of the product dimension. All of that is how we do dimensional modeling, is we try to identify the nouns within the company that the reporting uses, and what a company would be considered to give in terms of key performance indicators. How can we measure the success of our company or the different parts of our company? And dimensions and attributes are a big part of that construction, which allows us to look at the different aspects of the fact tables because they are connected to the fact tables. Now, the fact tables are events. So what is going on in an organization as an event? A sales order gets placed on a certain date and time. It has a certain amount. I'm going to talk about measures after this. Purchase order is the same thing. It's something that gets placed at a certain time, goes into a database with a timestamp on it. Inventory, how much inventory do I have for a certain product on this day? Hiring and attrition, their HR departments measures in terms of, are we hiring more, or are we firing or letting go of people more? And how do we measure those over time? And the measures in a fact table, what we want is we want to have keys that point to the dimensions that they're associated to, but we also then have the measures themselves. So for sales, amount would be a critical piece to measure on. Cost would be another one. So how much does this cost, and how much are we selling it for? And the metrics that we can build off that. Quantity on hand for inventory, and head count for HR. These are the measures that we determine inside the company as whether or not we're doing well based on this. When you do a dimensional model, you like to take the many fact tables with the shared dimensions. So you list them out. And this bus matrix is a key part of Kimball methodology. One of the deliverables for every contract I've ever been on is this bus matrix. And it's simply Excel where the A column here is the fact tables or business processes, and then listed across are your dimensions here. And where they interact with one another, they get an X in the middle. So sales order has a date to it. It has an item and it has customer. Doesn't have vendor because only vendor stuff we're buying, we're going to buy items from to make our products. All right, so I don't need, vendor's not going to be associated with sales order, but down here, bill of materials, you'll see vendor will be there because it's that's where the vendor comes into play. So we're not going to connect it to our sales order. But you can see here, there's a number of places where there are shared dimensions, items and everyone here, and we should have an X here for date in terms of the cost of an item if we have a fact table based on that. But that's key part of the dimensional modeling process, the bus matrix. And a dimensional model allows, once you have those shared dimensions across the fact tables, you pull it into, let's say, a third-party tool, and you create a model out of it. And that model has relationships from the fact tables to the dimensions. And analytics tools are typically equipped to handle this dimensional model. They'll identify if there's a foreign key on a fact table that's the same as a primary key on a dimension, and they'll create the relationship for you. And then once you have that relationship, then the third-party tool should just be drag and drop, filter and slice. And it makes analytics much more efficient from a reporting side, from an analytics side, so that people can do more analytics instead of building out the model itself. And tracking history. So this is one of the things we're going to demo. I'm going to show you what slowly changing dimension looks like. We're going to show you how a customer changed over time and how that got built into the process. And then once it gets built into the process, the fact table then pulls the right keys to point to that dimension. And once that's done, the user doesn't need to know about it. It's just in there and it's working. And that's where a dimensional model adds a ton of value to the analytics, to the analyst itself. Because again, they don't have to worry about a complicated query to write or have someone write it for them. Now, once the model is done, it's all tied together. We're going to show in the demo how that adds a ton of value. All right, so shared dimensions and type 2 dimensions. All right, I'm using Power BI as the third-party tool here. It could be any of the tools that are out there, as I mentioned, Cognos, Tableau, anything that you'd want to use from a dimensional model with. And you can see here, I've built my own very small dimensional model, but just to show how the sales and purchase orders are tied together. They both have a tie-in to the date dimension. Right, so when a purchase order is placed, it's on a date. Same thing with the sales, it's on a date. So I can track now, if I have this common dimension, date dimension, I should be able to see both metrics that are associated with each fact table and then sliced by date, or in this case, sliced by product. So we have product here is part of both my sales and both my purchase orders. And with that, I want to understand how do I go about reporting metrics on that now that I have my shared dimensional model all set to go. I'm going to go to this dashboard here, and you can see I have a list of products here. I've got 5 products. They are books. And this is all dummy data, so don't look to find the source on this. I just made it up. But what it can show then is if I want to see fact sales on those books. So I have an amount here. This is my measure from the sales fact table. And I just drag it on. Now you noticed I'm the analyst, and I want to see what's going on here. Now, as an analyst, I didn't do all this work behind the scenes. That's our data warehouse. Our data warehouse populated the dimensions. Our data warehouse then populated the fact tables, and we built a model and say a cube. Maybe in this case it would be considered a cube. And then now the analyst comes in and drags and drops. That's all they do. And you can see the breakdown here. It's very quick, it's very performant, and you can see the amount for each one. And if I wanted to then see a separate business process, my purchase orders, and see how that's doing, I just come over and I drag it again. Now, if I had to write a SQL query behind this, or if I pulled, let's say, a file in my data lake, and pulled that into a third-party tool. What would I have to do to set that up in order to produce something like this? And that's where a data model becomes very important. We've given the analyst a playground to just drag and drop on this. Now you can see with purchase amount and sales amount, I've broken it down by product because the relationship from product is on both of those fact tables. Now I also have date here, so if I want to click on 2020 and just see 2020, and you can see the whole report here is interacting with this particular thing. So if I click on 2019, these are my sales and my purchases for 2019 for each of these. And then this all work we did in the data warehouse to load the dimensional model, to load the data model. So the analyst now doesn't have to worry about it. And if you do that, the cost savings, again, if it's a 3-month or 6-month project and there's a lot of cost associated with that, the cost starts to come back to you over time because your analysts are spending the time doing good analytics instead of cobbling together different data sources. All right, so that's the benefit of shared dimensions. And I'm going to move right into the type 1, type 2. Now, this is tracking changes in history. And we're going to show a customer table. Obviously, there's not too many people in our customer table at this point, but it's going to show a very important concept. When we load our dimensions overnight, we have a business key that is associated with, in this case, myself. And every order that gets placed has this business key for customer. It says, hey, it's my ID in a certain system. Right? So with that order comes that business key. And we always underscore business key in data warehousing to make sure that people know what that is. But as you can see, I'm in here 3 times, and this is a primary key over here. Well, it's just an integer, but it's unique for every record. And in data warehousing speak, we call that a surrogate key, which is why I have this underscore SK at the end of it. And when I load in, we're trying to track changes. So the system every night, when it loads in the customer dimension, it says, this is the business key for AC Kinney. He's in the city of San Diego in the state of California. And every night it checks to see, has this changed? And if it changes, what happens? So in a type 2, I should go back, take a step back and mention type 1 attributes or SCD1. Type 1 is when you just overwrite something and you lose the history on it. And I guess someone's phone number is a prime example. If I had a phone number that was different in San Diego and then different in New Jersey, let's say, there's no real need to keep track of that change. No one's going to say, what was his analytics when he had this phone number as opposed to when he had this phone number. So when I update that, if I had a phone number column here and I changed when I moved to New Jersey, I would want all 3 of my records to have that new phone number, because I don't want someone reporting on 2018 data and trying to contact me and I still got that old phone number in there. Well, it's not useful. So in that case, it's a type 1 attribute. You just overwrite the history and it's gone. You can't report on the earlier value of it. And in this case, there's no need to, so we overwrite. And that's a type 1 dimension, a type 1 slowly changing dimension attribute, we should call it. Now, with city and state, this is important. I want to know what type of books I'm buying when I'm in this particular thing. So if you're marketing and you're selling books and you're saying, well, San Diego might have a whole different set of books we want to market than someone living in New Jersey. And so I want to track those numbers for when he was living in New Jersey as compared to when he was living in San Diego. And that's a type 2 change. And this is what this process is here. And it's one of the biggest value adds when you're doing a dimensional model. So with this, overnight, when it sees I live in San Diego, California, and it's the start date of 2018-05-01, and then all of a sudden on 2019-07-15, I move to Los Angeles. And so on that night when it's processing, it says, take the business key, AC Kinney, and where does he live? Oh, wait, we've got a change here. So instead of overriding that change, instead of having one record and just overriding San Diego with Los Angeles, I'm adding a new record in, and I'm putting a new date, a new start date for me. And when this first happened, I would have an end date of 9999-12/31, an unreachable date, just to show that it's the current record. We also have a flag here that says whether it's current or false. And then again, you can see on 4/30/2021, I moved to Randolph, New Jersey, and now I've got a new record, a third record that comes in with a start date, and then now this record gets updated to this unreachable date, and this gets set to true. And that's how my history gets kept in here. Now, the one thing that you'd say is, well, now if I'm doing analytics on this, I gotta know when the date is, and I have to pick the right record, so I gotta query that. And well, this gets handled again in the data warehouse, and this gets handled in a fact table processing manner. So in my fact table, what I want to do, and I'm going to show that, and I'm going to go back here for a second. If I'm looking at fact tables here, I've got my fact sales data, and these are my sales right now. And you can see there's an ID, primary key here, but there's my customer surrogate key here. And if you remember, my keys are actually 1, 2, and 3. So my sales are all the 1s and the 2s and the 3s in here. And there's other sales from other people. But when I built this fact table, I have a process overnight now. So my dimensions are loaded and my fact table processing goes, and it says, well, I have this business key, AC Kinney, and I have a date of the sale. And if that date fills in between, all right, so if that first date, well, let me just grab that date. That first date here is 2018-07-03. And if I go back to that customer table, when I'm building my fact table now, it says, okay, I know it's this business key, but where does the date fall in here? All right, so that first one here is 2018, so it's greater than this and less than that. So I'm going to use this surrogate key on the fact table. So that's important. The fact table gets built at night, and it brings in the right keys, right primary keys or surrogate keys from the dimensions it uses. Go to sales. So here I have 2 sales when I lived in San Diego because the timestamp was between that. Now I've grabbed a different surrogate key from when I lived in Los Angeles based on the timestamp and my business key. And then all the 3s down here are, these two purchases are from when I lived in New Jersey. And our fact table process picks up on that. It says, all right, when I select this, let's say I have a source view for my fact table, right? Sales order source. And in that view, I'm doing some transformation, some cleansing, different things like that. But in the end, it's the records that come out. And now I join it to my customer dimension on the business key. So I have my business key. I have this _BK at the end. I'm joining my dimension on that business key, but I'm also joining it on when the date entered is greater than or equal to my start date and less than my end date. And with that, in the select statement, I get the right surrogate key. The important part of this is this happens overnight. You don't need to know anything about it. You don't need to know the relationship of how the tables got populated. It's done. So once it's done, what can I do with it? Well, how does that help me? All right, so I'm looking at this table here, and it's just name of customers and the amounts that are here. And if I come over to my customer dimension, and now I want to see that, I want to see the breakdown here on state as well. Now, if I had overwritten the state value, if I didn't keep that history, and all of my sales will show up in New Jersey. And that's not good for analytics. I want to know what was bought when. So if I drop it in, you can see my amounts of when I lived in California versus I lived in New Jersey, because I'm tracking state as a type 2 attribute. And that's built in. Again, I just dragged and dropped and I got accurate results. I didn't need to know what took place behind the scenes. That's a huge value from a dimensional model perspective. If I could feel confident that my development team has done what they should do and it's been QA'd and set into production, and now I've got this wonderful data at the tip of my hands, and I don't even need to know how it does it. It's just doing it correctly. And say I wanted to now take that next step and break it down by city. Right, so you can see I have purchases in both Los Angeles and San Diego. And these all can be looked at over time too, because we have a date dimension here. And if I want to put a date key, now I can see the dates of each of my purchases and those of the other people as well. All right, so all of these dates, anything from Los Angeles should be in that 2019 time frame. You can see the San Diego ones were the early 2019 and 2018 stuff. And then in 2021, I made purchases living in Randolph, New Jersey. So you can see that that relationship has given me the history and allowing me to report on it in a number of different ways. So it's a huge value add for a dimensional model. People need to see this when they're, what this can do when they start the project. They need to have that example of, wow, if I do this like this, then we can just do drag and drop functionality. I'm going to go to the next slide and talk about one more piece of the dimensional model, very important. Date dimension, as mentioned earlier, if you have a date dimension hooked into it, you can have the one key from the date into the date dimension table, and then you can build out a ton of different things that work for you. You can have a lot of different columns that your business wants to see, maybe week ending date, certainly the calendar year and the fiscal calendar year. You want to build in work days and holidays into it. So I got flags for work days. And I know my holiday schedule, I'm off this Monday. So if that's a holiday, it's set to Y. And then I'm going to exclude holidays when I'm comparing my numbers against, let's say, a prior month or something to that effect. Anything that you can build into one date dimension. And then relative date columns. And a lot of the third-party tools that we're looking at all have that date or date intelligence built in so that you can do the type of things. But I'm going to just show a quick demo on the date and see how. So this is our date dimension here. You can see it's one table. It has calendar fields, month, quarter, year, all associated with the date field. That's my key right there. And with that, you know, instead of having to write a SQL function that says, give me the year of the date field, right? It's a fairly easy one to do in SQL, but you have to write it out and you have to do it. So I don't want to do it. I just want to drag it across and see it. So I can see I've got these years here. And if I want to see the numbers across year, I can just drag them out. And in any of these tools, you can then see it maybe as a bar chart. And since I have shared dimensions in there and my date dimension is shared to my purchase orders as well, if I want to see purchase order amount, I just drop it in. I don't know if that's a good visual. Maybe I should look at something like, yeah. Right, so I can see right now we had a lot more purchases than sales, so 2018 was tough. But you can see things got better, a little dip in 2020, and then 2021 was good, and it was starting off kind of a little laggy here. Maybe we should do something in terms of marketing or promotion. So that's the type of thing that once the data is already in there, the things we can do. And so you can also say as well, I don't want to look at it by calendar year. I have a fiscal calendar. All of our budgeting is based on fiscal calendar. So I'm going to take the year out, and I'm going to put the financial year. That's the fiscal calendar is their financial year. So I put that in the wrong spot, x-axis. So now I'm seeing it says 20, 21, 22 because their fiscal calendar starts in April. And I should just probably draw this across. If I throw this up here, you can see that get rid of this one, month name itself starts in April and it goes through to March. So their fiscal calendar is different. And it crosses over calendar years. So they're listed as 21, 22 or 19, 20. And so you have that ability. And it does also, if you're going to do, this might not be the right way to sort this. So I'm going to sort ascending. I want the right to left functionality going on there. So you can build that into your model too, so that even though it's so that you can sort in the correct way. What else with date? So one of the things with it, let me just show you a piece here. Then we're going to add a field to the date dimension, just as something it's a pretty simplistic date dimension. What does it take to add something to it? And we're adding it to a Power BI model. It should be added to it should be added to, give me a second here. Should be added to your data warehouse, which it will, but we'll add it here as a new column in a date dimension. And Power BI has its way of doing things. But if I wanted to add this particular calendar year month, maybe I want to see, I could see year and then I can slice down to month. But what if I want to see over the 4 years that I have, I want to see the year and the month. So I derive a new field and I add it to my date dimension. Oh, it looks like I've already put it in there. So once you do that, let's make it sake of demo. Let's do it right. So I'll add it as a different field. And so now instead of using my financial year here, I'm going to use calendar year month, drop it on here. And now I've got it over from 2018 August and all the months of the purchases and sales all the way across. And again, that's a value add that you can, date dimensions usually have hundreds of columns even, because there's so much you can do. Week ending dates, what was the prior day, so for today's, if my date is today, then my prior day is yesterday, and that flag can change every night in your data warehouse, and you now have the ability to always just filter on the prior day. There's a lot of things depending on the business and how they use dates, but you can all put it into this date dimension and it becomes drag and drop, just like in this example where I added that in quickly, drag and drop, it just works. Okay, just to finish off here, there's other pieces too. We're not going to do it in terms of a demo, but there are different types of fact tables that you can have. Snapshot fact tables, very useful for things like inventory and headcount in HR, things where what is my value for the particular day? Now, if I have 20, a quantity of 20 for an item one day, and then I've got 18 the next day because I sold 2, but then I bought 20, so now I've got 38, and every day I'm inserting those amounts. Now those amounts don't add up over time to give me an accurate picture. I don't, 20 plus 18 plus 30, it's not going to give me the right number about how much I have on hand. But snapshot tables in conjunction with, say, semi-additive measures, and then Power BI, other tools can handle semi-additive measures, say I'm not going to add it up over time, but I want to add it up over, let's say, product. I want to be able to say how many products were on hand on this day. But at the end of the month, if I want to see what my inventory was on a monthly basis, then I just want to see the last day of each month. And those semi-additive measures allow for that. There's a lot of functionality that can be done with different types of fact tables. Accumulating snapshot is another. If you want to look that up, it handles different updates for each entry. And many-to-many relationships. So we showed you the star schema which is essentially the one relationship from fact table to dimensions. But there are certain situations that require a many-to-many relationship to be built in and handled, and there are dimensional modeling processes for that as well. So just touching on a few of these other pieces to add to the value of having a dimensional model. Okay, and with that, Todd, I'm going to hand that back to you this time.
Okay, great. Thank you so much, Andy. In the scope of today's webinar, we have some offerings from Senturus to help you with your BI. If you need any help with business requirements, data modeling, your cloud and data architecture, both modernizations and migrations, data governance and administration, or reports and visualizations, we can help out with all of those. So please reach out. We'll have the contact information in a slide at the end. Additional resources. Have you seen our website? We recently just updated it and we provide hundreds of free resources on there. Go to the Knowledge Center on the website to get product reviews, tips, inside reviews, demos, and learn more about upcoming events like today's. Speaking of upcoming events, we have a great one coming up in a few weeks. We'll talk about pairing Cognos with Power BI and or Tableau. That's on July 14th, so please register on our website or use the link shown right there. Just stick with me for a couple seconds as we kind of go through just a brief Senturus overview. If you don't know who we are, we concentrate on BI modernizations and migrations across the entire BI stack. We provide a full spectrum of BI services, training in Power BI, Cognos, and Tableau, and proprietary software to accelerate bimodal and BI migrations. We particularly shine in a hybrid BI environment with some of our tools that we're currently using today. And finally, this isn't our first rodeo. We have been focused exclusively on business analytics for over 20 years. Our team is both large enough to meet all your business analytic needs, yet small enough to provide personal attention. And then we are hiring. If you are interested in joining us, we're always looking for skilled people in a number of positions, specifically a managing consultant. For the description of this position, as well as other openings, check out the careers site, the careers link on our website. Now the fun stuff, Q&A. We've got just a couple questions throughout the webinar today. I'm gonna go through those and feed them up to you, Andy, if that sounds good.
Okay.
First one is, what are some ways to connect multiple fact tables in a single model?
Yeah, so in going back to that the piece for the dimension model I showed, it is just that. If you have common dimensions, and something like customer is well, even product, right? Product is almost involved with everything. Now there's not for HR, it's not, but for product, if you are a manufacturing retail environment, it's essential that you when you build your data warehouse, that you combine it with as many fact tables as you can. So obviously purchase orders, sales orders, inventory. These are the pieces that you have a separate fact table for each, and each of those has one relationship to the product dimension. So when you do create your data warehouse, you're pulling in, you're loading and defining and loading your dimensions first, and then your fact tables will then have to check against those dimensions, much like it is here, to get the business key. Try and just highlight this piece here. So that's my join to the customer dimension. We're talking customer here. And it gives me the business key. And if I'm doing something else for customer, say invoices, I have a customer and I'll do the same thing. I'll left join on invoice and I'll have the customer key and then the date and join to my invoice dimension in the same statement here, and I'll come up with an invoice key. All right, so there are many dimensions that can be handled with multiple fact tables joining to many dimensions. And customer will be, I'm restating this one. Invoice would be a separate fact table that would join to the customer dimension as well. So you would have two fact tables, fact sales order and fact invoice, and both of those would join back to the customer dimension. Once that construct is in place, you are doing just what you have here in this demo. I'm showing the amount from one, and this is product here. So product is connected to both the fact sales order and the fact purchase order. And then you can see this breakdown once that construct has been made.
Perfect. Thank you. Another question about fact tables as well. Do you build the fact table completely new by loading, or do you load only the changes? And what about cancellations? Or how do you show retroactive changes in a customer dimension? Lots of questions in one there.
Yeah, so those are good data warehouse ETL questions. So with fact tables, you look to do the inserts, you look to handle deletes. So you bring in the data, and typically the way I've done it in the past is you will handle the inserts differently than you handle updates and deletions. And commonly there's not too many of the deletions. There's one client where I had a fact table that, even the same order could come in with a different amount. So it's a change in the order, not necessarily a deletion. And then we handled that by adding a new row for that change. So if it was 100 for the amount, then that order changed before it shipped. So they changed it from 100 down to 60. We put in a new row there with the change in it, and the change, that's how the company wanted that reported. So February was 100, a quantity of 100 of a particular item. Then they wanted that reported in February, and they wanted -40 reported in March, because now February's already been closed, and now we have to handle what went into in March's numbers. And well, we have to detract 40 because they changed the order before it shipped. So there are different techniques to handle, depending on the business processes and how the companies work. But yes, inserts, updates, deletes, they all need to be handled. They need to be handled efficiently, which can be challenging at times, depending on how much control you have over the source systems. So it is a good question. It's something that I think from a specific perspective, you have to come up with those techniques in order to handle it for your situation.
Okay. Last question is kind of a unique one. Are there different modeling approaches based on whether the database is row or a columnar database, aka like a SQL Server versus Vertica/Redshift?
I'm sorry, what was the question in there though?
Is there any difference to the way you model based on whether the database is like a row, standard row-based database like SQL Server versus like a columnar database like a Redshift?
Yes, and so Power BI here is also a columnar database, and by that it means that they are the old way of indexing is row-based indexing. It's kind of the standard way. It's been done for a while. Technologies in the last 15 years or so have shifted to columnar indexes, which is, so I might have 2 billion rows in a fact table, but I only have 200 customers, right? They're buying lots and lots of stuff, and with 200 customers, you can index those 200 more efficiently across the 2 billion rows. So instead of having 2 billion, an index 2 billion rows, an index built off the 200 customers, and that index based in the column things. Now, dimensional models, one of the reasons they came up with a new form of indexing, at least new 15 years ago, was because of the dimensional model data warehouse. Indexing that was created for transactional or application databases, row-based was very efficient and worked very well for that. But again, when you change your idea, we're using this database now to report, I want to see this 6 months compared to the prior 6 months. If you have a column indexing, it's going to be much more efficient. And in part, Kimball method was a big for that coming about. So yes, especially in each one of these things, if I have a product and I could have 300,000 rows in the product dimension, but if I have 6 colors that are available for these products, then it's going to index it on those 6 in that column, and it's much more efficient to handle it.
Great, thank you. So we are at the top of the hour. I want to thank Andy for his time today and this great presentation. I also want to thank everyone for joining us today and tuning in. Thank you.